Let's suppose that our experiment is to roll a die. We already know from our classical probability study that the probability that we would roll a 1 is 1 out of 6. There's one side that has one spot and there are 6 sides. But let's suppose that we were to roll this thing over and over. And let's say that we rolled a 2 and a 4 and then a 1 and then a 2 and then a 3 and then a 6 and then a 1 and then a 5. And how many times did we roll here? We rolled 1, 2, 3, 4, 5, 6, 7, 8 times. And of these 8 times, if we were doing an empirical study here, looking at a relative frequency, we would say that, well, we rolled a 1 twice out of 8 rolls. And from just these 8 rolls, we would say, well, the relative frequency is 0.25, but we already know that the probability that we would roll a 1 is 0.16 repeating, or approximately 0.17, 1 out of 6. So out of these 8 rolls, we were not particularly close to the actual probability of rolling a 1. So this is where the law of large numbers comes in. In doing empirical studies and calculating empirical probabilities from relative frequencies. If we were to keep doing this over and over and over and over and over until we had rolled it 100 times or 200 times or 500 times, then as the number of trials of the experiment increases, the relative frequency of the event, and in this case it is to roll a 1, increasingly tends toward the actual probability of rolling a 1. In this Excel spreadsheet, we have a simulation of rolling a die over and over. And each of these columns represent 20 rolls of the die. So these random numbers in these columns from 1 to 6 simulate this repeated roll of this die. In this row, we have the frequency, the number of times that the number 1 is rolled out of 20 rolls. Each one of these columns represents 20 rolls. In the next column, or in the next row, we have the cumulative frequency. So in other words, in the first 20 throws, 1 appeared 5 times. In the next 20 throws, it appeared 3 times for a total of 8. And in the next 20 throws, it appeared another 3 times for a total of 11. And on out. Then the next row gives us the total number of rolls as we continue through the process, going from column to column. So then this row gives us the relative frequency, the cumulative relative frequency for the number of times that 1 is rolled. So in the first 20 rolls, we had the number 1 come up 5 times. 5 out of 20 is 0.25. Then in the next 20 rolls, it came up 3 times. For a total of 8 out of 40 is 0.2. Then another 3 times for a total of 11 out of 60 is 0.18. So as we continue then through this spreadsheet, we see that this probability, or this relative frequency, is tending toward the actual probability of throwing a 1. In this last column, we have a total of 1,280 rolls by the time we get here. And the number 1 has appeared 220 times for a probability of 0.17. So let's look at a graph now of this trend. So this graph shows the relative frequency of the number 1 as we increase the number of times the experiment is conducted. Again, in that first column, we had 0.25 and then 0.2. And so we see what's happening here. It's kind of jumping around a little bit, and then it starts to settle in and settle in and settle in until it really starts to settle into that actual probability of throwing a 1. So from this, we can actually see the law of large numbers doing what it says it ought to do. As the number of trials of the experiment increases, the relative frequency tends toward the actual probability of the event.